This is TWiT.
Last Thursday's GitHub blog posting was titled, GitHub Brings Supply Chain Security Features to the Go Community. And it's very short. They said the global Go community embraced GitHub from the beginning, both as a place to collaborate on code and place to publish packages, leading to Go becoming one of the top 15 programming languages on GitHub today. We're excited to announce that GitHub's supply chain security features are now available for Go modules, which will help the Go community discover, report, and prevent security vulnerabilities. And then commenting on GitHub's announcement, Google's Go language, also GoLang product lead, Steve Francia, he said, Go was created in part to address the problem of managing dependencies in large-scale software. GitHub is the most popular host for open-source Go modules. The features announced today will help not just GitHub users, but anyone who depends, pardon the pun, on GitHub-hosted modules. We're thrilled that GitHub is investing in improvements that benefit the entire Go ecosystem, and we look forward to more collaborations with them in the future. Okay, so a little bit of background. The Go language itself is rapidly gaining ground, with 76% of respondents in a developer survey last year in 2020 saying that Go is now used in some form in the enterprise. So more than 3 out of 4 are saying, yep, we've got Go here. Go's module system was introduced 2 years ago in 2019 to make dependency management easier and version information more explicit. And as a consequence, Go module adoption is also increasing. 96% of those surveyed said that these modules are used for package management, which was a 7% increase over the previous year, 2019. And 87% of respondents reported that only Go modules are used for this purpose. And an overall trend in the survey appears to suggest the use of other package management tools is consequently decreasing. So Go did a good job with package management, and we're seeing, again, inertia is strong. If what you're doing is, not broken, the tendency is not to change it. But we're seeing a drift, but, maybe in this case, 7% a year. So GitHub's blog posting detailed 4 primary areas of improvement in supply chain security that are now available for Go modules. The first is GitHub's advisory database, which is an open source repository of vulnerability information containing over currently 150 Go advisories, and that number is growing every day as they curate existing vulnerabilities and triage newly discovered trouble. The database also allows developers to request CVE IDs for newly discovered security issues. GitHub also now provides the dependency graph, which can be used to monitor and analyze project dependencies through go.mod, as well as to alert users when vulnerable dependencies are detected. And GitHub has introduced Depend-a-Bot in this update, which will proactively, and I love this, send developers a notification when new vulnerabilities are discovered in Go modules that affect their projects. I'm sure our listeners all know how great I think it is that we're talking about proactive notification. Developers will still need to seriously heed any notifications they receive, but it's not possible to heed notifications that you never receive. So this is certainly a step in the right direction. And being proactive, I think, that is the future. Automatic pull requests can be enabled to patch vulnerable Go modules, and notification settings have been updated for fine-tuning. GitHub said that when repositories are set to automatically generate pull requests for security updates, dependencies tend to patch up to 40% faster than when they're not set automatically. And actually, I would think that would be even better than that. But, yay. So, we've talked, I would say incessantly on this podcast about the power that automated and automatic background updates have to rapidly remediate security vulnerabilities. Whenever I do this, I'm reminded by some of our intrepid listeners that with automation comes some risk of subversion. And yes, that's inarguably true. But for example, this month alone, Microsoft patched 117 flaws, 9 of which were 0 days. 4 of those were being actively exploited in the wild. As it is, Windows, as we've been talking about so far, is barely holding together. It's not possible any longer to conceive of a world without Windows automatic updates, where, as it was once upon a time, every individual end user was obligated to go get and manually install Windows updates onto their own systems. Can you imagine that today? And those old timers among us can probably recall the controversy that surrounded Microsoft's decision back when they made it to take that job out of our hands. Cranky old guys who were still imagining that they had any real control objected to the idea that their beloved hand-built machines might be changed without their private approval and oversight. Well, we had to get over it. That day has long since passed. And I believe we're headed much farther down that path. Like it or not, warts and all, it's the right path for us to take. In time, I think it's going to become just as clear that the only way for complex, multi-component, multi-sourced software to be built and maintained will be for similar dependency graph-driven automated supply chain management to become standard operating procedure. Developers are just as busy as end users, if not more so. And yes, it's true that automated supply chain management brings risk of supply chain attack. But we're heading in with our eyes open, and this is not the first time we've done this sort of thing. Automating the entire software lifecycle, from the developer's fingers on the keyboard writing the code, all the way out to code running on machines, even IoT devices, creating the ability to write and publish incremental updates, which then securely flow all the way out as binary updates everywhere that code appears, anywhere in the world, is where we need to eventually arrive. And yes, it will create a mess. It will be a mess of overhead that we do not yet have today. As an analogy, look at what a mess the addition of Secure Boot has created. An incredible amount of overhead that's beginning to appear in every system to address a problem that almost none of those systems will ever have. But it's there everywhere. And what does it do? All it does, when it isn't being bypassed, is attempt to assure that every step of the operating system boot process uses verifiably signed code. That's it. But it's a mess. In the future, we're going to muck up our development processes similarly because we have no choice. It's going to be a mess too, but I think it's as inevitable as was allowing Windows to update itself. It's just not possible, Leo, to imagine a world where the end users of Windows today are like responsible for keeping their systems secure. Thank God Microsoft did that back then, even though it did annoy those of us who used to know what the files on our hard drives actually did.